are you, my friends? This is Calculus 1 solved questions. In this video, we are trying to find the inflection points, if there is any, for some functions. And this is part 1, and you can expect also part 2. Question number 1, find all inflection points of the function f of x is equal to x to the power 4 minus 6x squared plus 1. Now, first we need f prime, which is 4x cubed minus 12x. Then we have to find the second derivative. It will be f double prime 12x squared minus 12. Take f double prime is equal to 0. Then 12 will be outside as a common factor. X squared minus 1. We can factor it into x plus 1, x minus 1. Then we have to do a table of signs to study f double prime. Remember, table of signs to study f double prime. So here we have x minus 1, x plus 1. We take a number here between minus infinity and minus 1. So these becomes negative. When you multiply them, you get positive. Here we get negative for any number between minus 1 and 1. And this is a positive. When you multiply, you get negative. And here you get positive. F double prime is positive. That means the function f here concaves up, this one here. F double prime is negative, the function concaves down, and f double prime is positive, the function concaves up. So when we have change in concavity here, this is the change in the sign of f double prime. So there is a inflection point here, and there is an inflection point there. Points where concavity changes. So minus 1, replace minus 1 in the function. Remember here, minus 1, f of minus 1. Minus 1 to the power 4, minus 6, minus 1 all squared, plus 1, you get minus 4. And you put 1 also in the function here, in f of 1, you get minus 4 also. So there are two inflection points, minus 1, minus 4, 1, and minus 4. And if you need more, f concaves downward on minus 1 to 1 here. F concaves up on minus infinity to minus 1, union 1 to infinity from the table of signs. Question number 2, nice. Find the sum of the coordinates of the inflection point of this function. F of x is x plus 2 to the power 1 over 5 plus 4. Now for the solution of question number 2, we have the function x plus 2 to the power 1 over 5 plus 4. Let's start with f prime of x. It will be 1 over 5, bring the power down, x plus 2 to the power 1 over 5 minus 1, which will be minus 4 over 5. Let's take now the second derivative, which is the derivative of the derivative. So 1 over 5 multiplied by minus 4 over 5 will be minus 4 over 25, x plus 2 to the power minus 4 over 5 minus 1, which is minus 9 over 5. We can write the second derivative as this. Now be careful here. Minus 4 divided by 25, and this will be down x plus 2 to the power 9 over 5. Now we need to do table of signs to study f double prime. So what are the points here that might be inflection points where f double prime is equal to 0? There is no value for x, and f double prime is undefined, so at minus 2. So we study f double prime, we do table of signs at minus 2. Now, this is negative here, so it will be counted in the table of sign. This positive 4, we don't take. This 25, we don't take. So we take minus, and this bracket here, x plus 2 to the power 9 over 5. Now, this is a minus 2. It might be inflection point or not. We have to check. So minus 2. Before minus 2, from minus infinity to minus 2. Let's take a number, let's say minus 10. Minus 10 plus 2 will be negative number. To the power 9 over 5, it's also a negative number, because this is the fifth root of minus 10, let's say minus 10 plus 2 to the power 9. So this is negative number, and there is a minus outside. So when you multiply them, you get positive. So f double prime is positive from minus infinity until minus 2. Let's try the other side, minus 2 to infinity. Let's take 7 or 8 or 50 or even 0. So we replace it here in the x plus 2, any number, they maybe 7 to the power 9 over 5, that's positive number, see, inside the bracket. And there is a minus outside, so that's a negative. F double prime is negative. So it concaves down, and this is concaving up. So we have change in the concavity. So we have at minus 2 is inflection point. We need to find the y value. So we replace minus 2 in the function. Remember, in the function, in the given function itself, minus 2 plus 2, that will be 0. To the power 1 over 5 is 0, plus 4, so that will be 4. So now the sum of the coordinates, this is the inflection point. The sum of the coordinates, you add them. If you need the product, you multiply them. If you need only the inflection point, this is the point, minus 2 and 4. Now, just more information here. F concaves up like this, from minus infinity to minus 2, and the function concaves down from minus 2 to plus infinity. Let's find all inflection points of this function. F of x is equal to x plus 25 over x. This is a little tricky question. So if you want to try it, guys, you can try it and then check the solution on the next slide. Now the given function is f of x is equal x plus 25 over x. We need f prime. Just note here, this is a sum, it's not a product. So we find the derivative of the first. Derivative of the x will be 1 plus the derivative of 25 over x. You can use quotient rule if you like, but easier to use reciprocal rule. 1 over f of x, so the function here is only x. So we leave 25, and there is a minus from the formula. So minus 25 over squared, x squared. If we need f double prime, the derivative of 1 is 0. Now this is minus 25, that's a constant. And there is a minus from the formula. We use, again, reciprocal rule. That will be minus 1. The derivative of x squared will be 2x over the function f of x squared. So we have x squared squared, which is x power 4. Cancel one of them with the x here, and minus with the minus. 2 times 25. The final answer for the second derivative is 50 over x cubed. So now we look for the values of x where f double prime is equal to 0, there is no value, or f prime double prime is undefined. So that will be at 0 here. So we make table of signs to study f double prime. We put here x cubed. If we take any number between minus infinity and 0, any number negative, cube it, it will be negative. Okay, so f double prime will be also negative. So the function here concaves down, see, minus infinity to 0. If we take any number between 0 and plus infinity, cube it, it will be plus. So f double prime will be plus. So we have the function here concaves up. So we have a change in concavity. See, this is a change in the concavity from minus to a plus. But why we don't have any inflection points? Now, there are no inflection points in this function because the domain of the function f, the given function, is r except 0. And 0, we have a change in concavity at 0, but it is not in the domain, unfortunately. So we cannot accept it as an inflection points. So that's a little tricky. Be careful, guys, there. For more questions on inflection points, you can see the lecture number 19. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.